Hi, everyone, and welcome to the Threat Briefing podcast from Vectra AI. I'm Lucie, and today I'm joined once again by our security researcher, Alex Groyz. You may remember Alex from our episode on the GenAI attack lifecycle, where we unpacked prompt injection and LLM jailbreak. This time, we'll talk about why attackers are targeting Bedrock instead of just using public LLMs. Alex, welcome back.
Thanks, Lucy. Thank you for having me back. I'm excited. So today we'll explore why attackers would target platforms like AWS Bedrock, and the value behind such attacks. But before we get into the specifics of why attackers would do such a thing, it's important to understand two key aspects of AI security. First, there is security of generative AI. This means protecting the models themselves, the interface APIs, and the sensitive data that powers these systems. This is what we will be discussing today. But second, there's something called security from generative AI. This means stopping attackers from using AI as a tool to create malware, run phishing campaigns, or spread false or harmful information. When we look at attackers, some groups are motivated for financial gain. They want to exploit AI platforms directly for profit. Other groups use AI for weaponization to enhance attacks, conduct disinformation campaigns, or carry out reconnaissance. So we won't discuss the second aspect today, but I wanted to mention it here mainly to highlight the difference and set the stage for understanding of why attackers might spend the effort to compromise a service like Bedrock rather than just target a public-facing GenAI app with clever prompts. To build on that foundation, it's important to understand that not all GenAI systems present the same attack surface, especially from attackers' perspective. Attack surfaces depend on the type of GenAI deployment. At the top, consumer apps like ChatGPT get attacked mostly through direct prompt injection. Attackers try to jailbreak models or get it to say things it shouldn't. Now, the value here is limited. Usually it's just for novelty or disinformation. Next, we have enterprise apps like Copilot or RAG-based tools that connect deeper into organizational data. Attackers often use indirect prompt injection here, like poisoning documents or repositories to leak data. And this could lead to real financial impact, especially if the sensitive data is exposed. And finally, we have cloud GenAI platforms like AWS Bedrock, where the real large attacks happen. Attackers with access can interact with the model directly. They can bypass guardrails and abuse compute resources or exfiltrate large amounts of data. This is where LLMjacking happens, and the blast radius can affect the entire organization.
Why would attackers target platforms like AWS Bedrock instead of public or open source models?
Yeah, so let's break down why attackers would specifically target platforms like AWS Bedrock. First, they want direct access to powerful models. Unlike public apps, Bedrock provides programmatic API access. This allows attackers to bypass guardrails, test jailbreak payloads, or misuse the model at scale. Second, there's the monetization angle. With access to the interface APIs, attackers can run expensive queries on the victim's account. This type of abuse is often called LLMjacking, and you'll hear me use that term often here. It's like crypto mining, but using AI compute resources instead. And third, attackers could leverage enterprise data. Many applications built on Bedrock connect to internal data through RAG pipelines, plugins, or agents. So if these connections are misconfigured or overly permissive, attackers can pivot into sensitive documents, leading to breaches and data leaks.
And how do attackers gain access to inference APIs? What initial access techniques do you observe?
So when we look at how attackers gain access to AWS Bedrock or similar platforms, the pattern is very clear. It's almost always about valid credentials. This isn't about fancy exploits or breaking through cloud defenses. It's almost in every documented case, whether it's from Microsoft's investigations or LLMjacking incidents, attackers use stolen or exposed cloud credentials. These credentials come from many places. Sometimes they're hard-coded in accidentally exposed files. Other times, attackers target service credentials from vulnerable applications. Many times, the keys belong to non-human identities like CI/CD pipelines, reverse proxies, or automated services with persistent access. Once attackers have these keys, they use automated tools to see which services they have access to. If Bedrock is enabled, or it can be enabled with a few API calls, it instantly becomes a target for abuse. This isn't theoretical, it's real world, low friction access using valid credentials.
What does LLMjacking look like in a cloud native environment like Bedrock?
So let's take a look at one hypothetical example. This is what possibly would look like an AWS Bedrock LLMjacking attack. So first, an attacker would exploit a public-facing application running on an EC2 instance, most likely through remote code execution. This gives them access to temporary credentials through instance metadata service. With these stolen keys, the attacker would quietly run test prompt against AWS Bedrock using the invoked model API to confirm if the service is active and if the usage is billable. Once they confirm access, they can set up a proxy tunnel that funnels requests from external users directly into Bedrock, bypassing organizational defenses. This proxy would then be monetized as a pay-to-use API, letting anyone bypass Bedrock guardrails and run LLM prompts at scale, all billed back to the victim. There has been several documented cases of this, so let's take a look at a real-world example. Here's what an LLMjacking case would look like in a full-blown business operation, as carried out by Storm 2139, a global crime group tracked by Microsoft. They first scraped thousands of exposed cloud credentials from public sources like repositories and configuration leaks. With those valid keys, they logged in and disabled content filters, effectively removing guardrails from Azure OpenAI service. Then they packaged the unrestricted access into a reverse proxy marketplace, basically reselling the AI capacity as a service. Customers of this proxy generated illicit content, including deepfake imagery, completely bypassing normal safety controls. Meanwhile, Storm 2139 operators collected access fees and monetized usage, all billed back to the original key owners. So the example here shows that abuse of GenAI platforms isn't just a AWS Bedrock issue, it's a risk across any cloud provider that offers these type of services.
What detection blind spots exist in traditional cloud monitoring tools when it comes to GenAI abuse?
In traditional cloud monitoring tools, there are some limitations when it comes to detecting abuse of generative AI services. First, with cloud native logs, there's no prompt level visibility. Services like AWS CloudTrail capture who called the model, but they don't capture the actual prompt text or the model responses. This means harmful or suspicious prompts could go unnoticed. Second, billing alerts and usage anomalies detections could lag. It may take up to 24 hours for unusual spending patterns to be identified. So attackers could run costly queries and the alarms won't go off. And third, when safety filters or guardrails block or modify prompts, those actions are usually logged at the application level. They don't appear in cloud native logs, making it harder to detect attempts to bypass controls. So together, these gaps make it easier for attackers to abuse GenAI applications without being detected until serious damage happens. So here are some practical steps to defend against LLM jacking or other types of cloud GenAI platform abuse. So first, secure identity and access management. Avoid overly permissive IAM roles. Make sure that individual user identities are passed through to your RAG and LLM layers to reduce risk. Second, gain prompt level visibility by logging prompts, model responses, and RAG queries. Feed these logs into your monitoring system so you could detect malicious or unusual activity early. And at the same time, you should enable real-time guardrail telemetry. Whenever a prompt is blocked or filtered, that event should be logged and monitored centrally and alert you on suspicious attempts. And finally, closely track usage and spending. Set tight thresholds on sudden spikes in usage and anomalies. So all of these steps will give you a better security for your cloud generated by AI services.
Thank you very much, Alex, for your valuable insights. That was very interesting.
Thank you, Lucie.
So that's a wrap on this episode of Threat Briefing. If you missed our earlier episode with Alex on the GenAI attack lifecycle, be sure to check it out for a broader look at how attackers are targeting AI across the full kill chain. Subscribe to the podcast for more research-driven briefings and stay tuned for upcoming episodes. Thank you for listening. We'll see you next time. Bye.